Okay, so in this video you will learn about a topic in physics called change of phase. Only the calculation part. So I will explain about the formulas that you are going to use, in finding the amount of energy needed for a substance to change its phase. Whether it is becoming solid from liquid, or vice versa, or liquid to gas, or gas to liquid. Here I will draw a simple diagram for you with the bottom one written as solid, and then liquid, and then followed by gas. And I draw an arrow here facing upward. It says energy here, meaning the solid has the lowest level of energy among all, while if you add more energy to the solid phase of a substance, then at some point the solid will change into liquid. Liquid, if you add more energy to it, it receives some energy and the liquid changes into gas. If you go and give a lot of energy to gas, it will eventually becomes plasma. But plasma is not the topic that we are going to discuss in this video. So this simple diagram could really help you in understanding about the flow of the energy, whether it is whether the substance receives energy or release energy, and what will it become if it receives enough energy or releases enough energy. Okay, and I will do a little bit review about the formula that you already learned, which is Q equals mc delta T. This formula is used for finding the amount of heat released or received when there is a change in temperature happening to the substance. Okay. It depends on the amount of the substance itself, the specific heat capacity, and the amount of increase in temperature. So the more the three of them, then the more the amount of energy needed. So this is very an easy concept, and we already learned this. This one is just to calculate the amount of energy needed when there is a change in temperature, but not for phase changing. This formula cannot accommodate calculating the amount of energy needed for phase changing. So here I will write no change in phase. The phase remains the same. So if you are starting with the liquid water, the limit of the temperature of the liquid water should be 0 and 100 Celsius degree, because if you go beyond that, it will change into other phase, and this formula cannot be used anymore if you go beyond that, if there's a change of phase. In order to find the amount of energy needed for the phase to change from solid to liquid, liquid to gas, or the other way, you need this second formula, Q equals ml. So Q here, I will write it down, is the quantity of heat, and the unit is in joule. You can also use calories and so on. M here is the mass of the substance, and the SI unit for that is kilogram. L here is latent heat. The unit is joule per kilogram, or you can use calorie per kilogram, calorie per gram, it is up to you. Joule per kilogram. What is the meaning of latent heat? It means that how much energy is required to change the phase of an object by some amount of mass of the substance. That is the meaning of the latent heat. So 100 joule per kilogram for a substance A, it means that you need to give 100 joule for a substance A that has 1 kilogram of mass to change into other phase. If you give it, it will change into higher energy phase. If you release it, it will change into lower energy phase. So that is the meaning of latent heat. Okay. Now I will draw a diagram and explain to you about the phase changes of water. We use water because it is the most common substance, and we often experience the water in 3 phases, which is the first one, ice, liquid, and water vapor. So I'll draw a diagram here, X and Y, with X here as the amount of energy given to the substance, and the unit is in calories. And here on the y-axis we use temperature with Celsius degree as the unit. We will start from the lowest level of energy of water phase, which is an ice, and we will start with negative 50 Celsius degree, and absolutely water will be is in ice form in that degree. And here is the 0 Celsius degree as the barrier to become liquid water. And then at this point I will write 100 Celsius degree. Okay, so in this form, ice, water is in ice form. Yeah, it is solid. Okay, and then if you heat the ice, if you give energy to the ice, so it will increase in temperature. The more the energy something has, the more the temperature. In particular, it has more average kinetic energy in translational way. So temperature is measure of the average kinetic energy of molecules in the substance. And the kinetic energy type is translational kinetic energy, not the rotational kinetic energy. If you start here and then you give energy to the ice, so it will increase, and until 0 Celsius degree it will have some adjustment. It cannot directly increase in temperature because it needs to change its phase first, which is changing its phase from solid to liquid. Okay. And it is described here. When something, the solid, wants to change into liquid, it requires a process. It is not an instant process. So this is the process of changing from the solid water to liquid water. And then at some point, at this point it will all be liquid water, no ice at all. And if you give more energy to the water, it will increase in temperature. Until this point, 100 Celsius degree, it is the beginning of changing the phase from liquid to gas. And I will draw it long, and I will explain to you later why. And then after all of them become water vapor, if you give more energy, it will increase in temperature. Okay, so this triangle part is where the water is in ice form, and here the process of it contains not only ice but ice and liquid water. So in 0 Celsius degree, water can be in ice and liquid form. And at this part, at this trapezoid, everything is liquid. And at this big rectangular here, the water is in liquid form and water vapor. And the rest is water vapor. So you see here, if you, let's say that the substance that we use is, we started from negative 50 Celsius degree, so it is an ice, and let's say we use 1 gram of ice, and then after the ice is starting to change its phase in this stage, so this is where you need this formula Q equals ml, because in this stage there is no change in temperature. The line is just flat. There's no increase in temperature at all. No y-axis here. So in this stage you need this formula. And how do we know that this amount of water needs some energy? So at this point, it requires 80 calories in order for the ice, 1 gram ice becomes 1 gram liquid water. And there's a constant for that, the latent heat of fusion, which is 80 calories per gram. Here it means that the 1 gram ice needs 80 calories to become 1 gram of liquid water, all of them. And then after all of them becomes liquid water, so if you want to calculate the amount of energy needed in order to raise the temperature of the 1 gram liquid, so you use this formula Q equals mc delta T. And after it reach this point, the point where it is the start of phase changing, it requires 540 calories for the 1 gram liquid water to change into 1 gram water vapor. Therefore, the latent heat for vaporization for liquid water to water vapor is 540 calories per gram. What is the meaning of this? 540 calories per gram means that in order to change 1 gram of liquid water to 1 gram of water vapor, you need 540 calories. This is 6 times more than the amount of energy needed to change the same amount of substance from ice to liquid water. And then the rest is when all of them has become water vapor, it is the rest is just a change in temperature if you add more energy to it. So I will write down the formula in where you need to use Q equals ml. Basically, you just look at the flat lines here. Means that there is no change in temperature, but there is only change of phase happening there. So in these two places here, you need Q equals ml. Now this example is when the substance receives energy. So if the substance release energy, means that from gas to liquid and then to solid, you still use the same formula, but the meaning of the Q here is not amount of energy received, but it is amount of energy released by the substance. Later I will give you some examples about how to use this formula, so that you have some ideas about this.